Hello, everyone. Welcome back to Advent of Code 2023. We're going to do day 18 today, but first, as I sometimes do, I wanted to show you a few changes I made to the previous day overnight. I poked around a bit more in linear, the package that comes with V2 and all the other linear algebra stuff I'm mostly not using, for functions of the type that I wanted. And I realized we can simplify the neighbor computation a bit. I had written this here, unit x, unit y, minus unit x, minus unit y, because unit gives you like the unit vector in a direction. And that seems fine. It's a little repetitive to write out all four of these, but it seemed okay. However, all this stuff in linear algebra was talking about basis spaces, and I don't really know what a basis space is. I did actually take a linear algebra course once, if you can believe it. But this was a long time ago, and it was not my strongest subject. I was much better at the kind of calculus direction than the linear algebra direction. So if I ever knew what a basis space was, I've forgotten. But from reading the docs on linear vector, basis seems to be it just gives you a list of all the unit vectors. Well, of one unit vector per axis, basically. So it gives you the unit x and the unit y vector. So instead of having to write all this out, I said, take the basis vector, and then give me both the negated and normal versions of those. And then this is the same, except I realized there's no reason really for negated to import that. Because since vectors are numberable, you can just call negate on a vector as if it were a number, and it negates both dimensions, both components. Anyway. So this is nicer, I think. I feel like there's got to be some way to avoid this guard thing. I don't know, but I didn't figure it out. And then there's also a tiny unrelated change in this commit because I'm a bad developer. It really should have been separate because it is not covered by this commit message, simplify neighbor listing. I just committed at the same time. What did I do here? I renamed I don't know. I mean, this is just some minor algebraic shuffling, nothing very interesting here. But let me define a function with a more useful name and make the go function a little bit clearer, right? It's illegal if it's out of bounds or the momentum is too high. Rather than I would say if it's illegal if it's not in the range of B, whatever. So, and the second thing I did was more interesting. I saw someone else's solution which didn't have this momentum tracking at all in the grid. And a lot of people solved it this way. I mean, a lot of people also solved it the way I did. But instead of moving one step forward, instead of the way I did it originally was I would move one step and update the momentum. And if the momentum was too small, then I would say you're not allowed to turn. But if the momentum was too big, I would say you have to turn, kind of, right? And it was a little bit awkward to actually do that, but that was basically what I was doing. What that ends up meaning, though, is that you offer the search. You clutter up the search space a bit because you're frequently considering making moves that are illegal, right? You go one step in a direction, and you're like, oh, I'll try turning, which you can't do. I'll try turning left. I'll try turning right, right? Which you can't do because you have too much forward momentum, or not. You haven't moved forward enough time, so you're not allowed to turn yet for part 2. And so what you can do instead is This neighbors function, instead of just generating a list of one-step directions you could go in, it can generate a list of the vectors, like a list of all the points you could go to and then immediately turn, if that makes sense. So with the wobbliness factor from, I mean, what was, oops, don't scroll all the way to the bottom. In part 2, what was the wobbliness again? 4 to 10. So we would generate move forward 4 times, or, well, not forward, because this neighbors function mostly assumes that you have already finished traveling forward and are now definitely going to either turn left or turn right. And so it generates the list of points like, oh, you could turn left and then move 3. Or 4, I guess 4. And then it's, oh, you could also turn left and move 5. Or you could turn left and move 6. Or you could turn left and move 7, all the way up to 10. And likewise for the right. And it never offers to let you go forward or backward. In this way, you know every time you're calling neighbors, like, that you have to turn. And you're going to have to go straight for a while. And so you don't have to keep checking that every time you make one step. There is a slight complication that it makes the beginning a little bit more complicated, maybe. I think. Or does it actually make it simpler? It actually looks like it might be simpler. Because you don't have to special case the 0 thing saying that you're allowed to continue straight. So that's why this delta is gone. Or this is in the diff. It does mean, however, and this was after I implemented this like big step translation, it was wrong for a while, and I couldn't figure out why, and I went to bed. And when I woke up, I had the answer, which was this line here. I was saying make sure you don't go backward, but I forgot that with this new big step, you're never going forward. You're always turning left or right at each step. So I said, oh, make sure you don't go in the D direction or the negative D direction. So there's almost some linear algebra version of this where you can take D prime and just generate, or you can take D, and instead of trying all 4 directions and throwing away the 2 that are like forward and backward, there's maybe some way you could say, find me the lefts and the rights. And there totally is. You can ask linear algebra, please tell me the clockwise, the vector that's clockwise from this. And then you could negate that, and you'd have the vector that's counterclockwise. The problem is that we start with a momentum of 0, allowing us to go either way. So I just said generate all 4, throw away the ones that are illegal. And then the rest of it is updating the rest of the code to deal with this big step thing. Like cost now has to consider nodes that aren't adjacent, so it has to map over the array all the squares you're entering and compute the total sum of the cost. Now, I realized like today that you could optimize this a little because we're consulting the array more times than necessary now, because we say, oh, I could go from, I could go from here to 5 squares away or here to 6 squares away. And each time we're computing afresh. What's the cost for moving from here to 5 away? What's the cost for moving from here to 6 away? But of course, the cost from here to 6 away is just like one number more than the cost for 5 away. So we're doing a little bit more work than necessary. We could use A star assoc instead of A star, so that instead of giving it, oh, here's the neighbors we can take, and then it says, oh, what does each of these cost? We could have just said, here's the walks you could take and the costs they have. Although then you couldn't really do the pruning of the out of bounds, so I don't know. Maybe you could. Probably not. Illegal had to be, well, it was simplified because we're not tracking wobbliness anymore. We're not tracking momentum, so we don't need to use the wobbliness to figure out whether a move is illegal anymore. And solved doesn't need a wobbliness anymore either. It says, oh, well, if you managed to stop on the exit and it was legal to turn here, then you must be done. and then we just had to update solve in part 1 a bit. I think that covers everything we did. Yeah. Cool. So, on, I suppose... Oh, I have this open still, but I don't need it. To day 18. And I have to be honest, I have been sort of putting this off. I read the problem statement, and I wasn't enchanted by it. It seems like we already did some... I mean, I'm sure part 2 will be something novel, but part 1 is something we've kind of already done this year. And I was like, ugh, do I really want to do this? But it would be nice to finish Advent of Code this year. We'll see. As I said at the beginning of the playlist, I offer no promises. I'll keep doing it as long as it's fun. And I'll stop when it isn't. Today might be a bit of a grind, but we'll see. Day 18, Lava Duct Lagoon. Thanks to your efforts, the Machine Parts Factory is one of the first factories up and running since the lava fall came back. However, to catch up with the large backlog of parts requests, the factory will also need a large supply of lava for a while. The elves have already started creating a large lagoon nearby for this purpose. However, they aren't sure the lagoon will be big enough. They've asked you to take a look at the dig plan, your puzzle input. For example, this. The digger starts in a 1 meter cube hole in the ground. They then dig the specified number of meters up, down, left, or right, clearing full 1 meter cubes as they go. The directions are given as seen from above. So if up were north, then right would be east, and so on. I don't quite know why they don't just say north, east, south, and west. Anyway, each trench is also listed with the color that the edge of the trench should be painted as an RGB hexadecimal color code. Viewed from above, the above example dig plan will result in the following loop of trench having been dug out from otherwise ground level terrain. So let's see. We start somewhere and we go right 6. That must be here. 1, 2, 3, 4, 5, 6. Yep. Yeah, clearing full 1 meter cubes as they go, so fine. At this point, the trench would contain 36 cubic meters, or could contain 36 cubic meters of lava. That's the perimeter. However, this is just the edge of the lagoon. The next step is to dig out the interior so that it is 1 meter deep as well. Now the lagoon can contain a much more respectable 62 cubic meters of lava. While the interior is dug out, the edges are also painted according to the color codes in the dig plan. The elves are concerned that the lagoon won't be large enough. If they follow their dig plan, how many cubic meters of lava could it hold? So, one thing should stick out as ominous to you, which is the color code. They haven't mentioned any meaning that it has. So surely it will be used for something in part 2. I don't really know. I don't have any idea what it could do, right? I don't think any of these colors are the same either, right? They look like they're all distinct. Although these two are really close. What's that all about? So, I don't know. Hopefully, I don't know. Are they gonna make me convert this dig plan to text based on the color or something somehow? I don't know. So I mentioned that we did this already. I don't remember which day it was that had us figuring out the area for something. I suppose I could find out pretty quickly by a quick search on the Discord. Was it day 10? Yeah, day 10. Right, this was the day we had a description of pipes to figure out the shape of an area, and then we had to figure out how much space was inside the area, even though it could loop around itself and we counted like um, we counted how much was inside the pipe's enclosed area. And honestly, part 1 looks like a much simpler version of part 2 from day 10. Um, really, even like, I don't know, part. It looks easier than part 1 of day 10 as well, to be honest. Because figuring out how the pipe's connected and what pipe the start tile was not the absolutely most trivial thing in the world. But we shouldn't have like a hugely problematic time with this. Like, I think we can kind of scan L through these instructions and get out a list of all the cells and how they're painted. Then once I've done that, I don't know. We could compute the area the same way we did on day 10, right? Scan each row starting from the left and count how many times you've crossed the trench perimeter, right? It's not necessarily something we have to do this time, though, because when we're on the trench perimeter, I don't know. It seems like it would be fine. I wonder, though, about doing like a flood fill instead, where we somehow locate 2 cells that are definitely on opposite sides of the trench, and from each of them we search. Okay, is this the inside or the outside? And for the one that we find out is the inside, we fill it in. Like you just search for you do a search over all from a node going to the node's neighbors until you either find the outside or you never find the outside. Actually, that doesn't seem like it's going to work very well, does it? Because even if you find an empty space that's inside the trench, it might not be connected to all the other empty spaces within the trench. There might be a narrow choke point where the trench is just 1 or 2 wide with no empty space between. So such an approach would have to cross over the trench, at which point you might as well use the just scan row by row anyway, I think. I think I would like to use an array this time instead of a set like I did on day 10. I'm a little more practiced with arrays now. And B, we might need more information somehow about, like, I don't know. I mean, I guess I could use a set, but well, yeah, I don't see any reason why I would need to, right? I just want to scan the whole grid from left to right, and boy, if there's one thing arrays are good at, it's being scanned left to right in row major order. So that seems pretty good. Yeah, I think an array would have been a better data structure on day 10 as well, in retrospect. Although, I don't know. Maybe not. Yeah, it would have. Anyway, let's get started, I guess. We can go look at my input file. 604 things. Fine. I'd sort of be interested to know before we get started, like how many distinct colors there are, even, right? I imagine it's going to be something like, oh, only lava that is closest to a wall that is more green than any other color actually counts, or something like that. That's my guess about what part 2 is going to be. We'll see. Let's get our parser first. We definitely want a regex today. There have been a few days where it's been simpler to just use like the built-in text processing libraries, but not this one, I think. Equal tilde. Surely we need some. We probably want a digit or a decimal, which we can get. Yeah. Let's take sim as well. And I guess I'll turn on overloaded strings, right? I mean, why, right? I guess basically just for the spaces in between the numbers and the colors. I'll just import string, it's fine. Decimal, please. So let's just, I think, well, we're going to need a data type for our, before we can write a parser, we need a data type to parse to. Let's say data, do they say what the name of their steps is or anything? No. Fine. Data, step? Data trench walk? Data, what are we calling this? Direction? Sure, we'll call it, well, direction is north, south, east, and west, though. We'll call it an order, because it's an order to the digger in their little manifest. Is an order containing a direction, an int, and a color. I don't think I need equal for anything here, right? Just derive show. Oh, I haven't updated this thing to be in the right. There we go. And also, I guess I should add array and linear to my. Yeah. Okay. Cool. I guess I have to restart GHCI, right? Okay. Now, I don't know why our directions are framed as right, down, up, and left instead of north, south, east, and west. Certainly you could imagine that part 2 might be, oh, actually we were confused. Right and left were meant to be interpreted relative to the direction you went last time or something. It's actually a totally different shape. But since there's already the colors as something that part 1 doesn't deal with, I imagine part 2 is going to mostly be about the colors and not about changing your interpretation of the instructions. So probably we'll just have like north, south, east, and west. But I think we just want, like, we want to use v2, right? Import linear.v2. Put a space there, you weirdo. Okay. And we'll just have a direction be a v2 that we know is going to be a unit, basically. I don't know. Let's have actually type. I don't know. Whatever. We'll just repeat v2 int everywhere we need to. Type color. That's just a string. So we're storing a v2, an int, and a color, and that's all the fidelity we really need, right? So prepare, I think, is going to be the same thing it is every day, Pinky. Okay. Need to import data maybe. Actually, let's just update my template, but I don't know. It's too late in the year. I don't want to do it. I'll just edit it every day like an idiot. Where input is many line, or some line, excuse me. Actually, why say line? Some direction followed by a new line. And a direction is no, it's an order, not a direction. An order is order of direction space decimal string space left parent hash, I think. Yeah. Well, you know what? Let's say actually that it's just a sim space and then a color. Now our color is sim of, no, it's string of open parent hash ignored, and then replicate M6 any sim. I guess I need to import that, huh? I need replicate M as well. And then a closed parent. A direction. Yes, we haven't yet written. I mean, our direction type is just a v2 event, so we have the right. I don't know. Well, let's just try a sum of, where is that from? Here. Why do I want this to be a list and then a summit? I don't know. It just seems right. Sim u. In that case, we want I want like negative of unit of y, right? Oh, this should be capital U. Or was it in vector or v2? I don't know. Unit. Can I just say minus here? I don't know. As an aside, Haskell's relationship with the minus operator is kind of psychotic. Because it's like the one thing that needs to be both binary and unary as an operator. And Haskell really doesn't like that. It's not like specially blessed by the language mostly. Most operators in Haskell are not specially blessed by the language like they are in other languages, right? You know, the parser needs to know about how stuff is parsed. You've got a table of operators and whatever, and it can just handle minus x and y minus x can just both be legal grammar productions. But in Haskell, like, all operators are equal, pretty much, right? You can tell Haskell what precedence they should have, and like the type system tells you what arguments they have, but none of them are baked into the language, except minus, which is actually special. And so I'm always a little bit confused about how to use it. Like, what happens if I write minus of a non-number? Do I get the negative version of that number, or do I get a curried partial application of subtraction involving that number? I think I must get minus of that number, right? Because otherwise you wouldn't need the subtract function for anything. So I think you can just write minus. We'll find out. Minus of unit. I need. Actually, where? No, wrong window. Is this what I want? Where are x and y? Okay, that must have been removed in previous commit. Okay, unit is in vector. But x and y are in v2. Okay, fine. Well, actually, I don't think I need these parents, right? I don't need this parenthesis. Minus unit of x if there's a left. Unit of y if there's a down. A unit of x if there is a right. Does this type check at all? Oh, I forgot to write sim. Okay, it does type check. Great. So this is enough, by the way, to tell me that I didn't mess up what any of these pointing at things were. The call to order wouldn't type check unless I had gotten this all right. I have a direction, a number, and a string. And there's only one place that those things could have come from, which is that these ignore symbols were... The operator precedence was what I hoped it was. I know, in the comments, you can light me up if you want. I can never remember anything about operator precedence or how to take advantage of it. I'm just too Lisp pilled from my years working in Clojure. Okay, so now we can try, I guess. Let's just say prepare of read file of input.txt, right? Does it parse? Nope. Great. Good to know. Thanks for the tip. Why not? So an input is some orders. We parse a direction. There's a space and then a decimal. Actually, is the input regularly spaced? What happens with... It does look that way. Yeah, there's always exactly one space here. And... Huh. RUDNL. Yeah, those are the... Oh, hang on. Was something weird on that line? No, there were just two things in a row that were 2 digits and it stuck out a bit. Yeah, I don't know. This looks right to me. So I have... Oh, whoops. This should be a hash. There we go. There. Now it parses. Okay, great. So one thing I wanted to check was import data.set qualified as s. I mean, actually, I should just write this in the main program. Oops. Did I make a mistake there? No? Okay, I copied correctly. Okay, whatever. So what I wanted to do was s size of s from list map. Okay, let's actually do a little bit. I don't know. I could make this a record so that there's an easy record accessor function for the colors. I really think in my code, in my real non-REPL code, I'm just going to want a pattern match on order and get out all things every time, right? So maybe it's kind of silly to give it a record accessor. So let's just map lambda order, lambda, I don't know, parentheses, C to C. There are 604 unique colors, huh? And isn't that about what we said, how many lines there were? Yeah, there are 604 lines. So every color is unique. That's interesting. That was how it looked when I looked at the input as well, right? They were all unique, but like a couple of them were weirdly close together. Okay, well, good to know, I guess. I mean, I guess I could commit the parser at this point if I wanted. There have been days when I've done that. Like years when I've done that. But I don't know. Parsing is getting pretty blasé these days. I don't really worry that I'm going to mess up the parser now. Like, there's nothing I'm going to do in my implementation of part 1 that's going to make me wish I had checked in the parser, is all I'm saying. So what do I do now? I just implement turning it into an array, actually, right? Yeah, of course. Yeah. So let's import data array array, because this should be immutable, right? We need the array type. We need the list array function. Are we going to need bounds? Maybe. Sorry, I just got distracted thinking about like how to some alternate ways we could compute the bounds of the array. I mean, I don't know. It's just dumb. There was one day when we did like without using regexes, we parsed the input into like a list. The input is already a list of char, right? It's a single string. If you call lines on it, you get a list. The input is a string. You call lines, you get a list of string, which is a list of char. And so you can get the bounds out of that by just calling like length of the first and length of the last, and length of the line and length of the number of lines. It's a little bit wasteful, right? You're not supposed to call length if you have another choice, because it's like inefficient for large lists to traverse them for no reason. Obviously, we have small lists, so it would be fine. But I'm kind of like, it would be kind of cute to have some stateful computation that, like, while we're processing the input list, we also count the number of lines and the length of each line, and we like output that to using writer. So our applicative wouldn't just be regex, it would be compose regex with writer or something like that. Does that make any sense to me? It would be like an RE of char of writer of v2 of int and order, or list of order, or something like that. That would be the type I would have. 'Cause I could emit, like, as I'm parsing, I could figure out the coordinates of each tile. Oh, but wait, sorry. We don't have the grid. We're not reading in a grid. We're reading in a list of instructions. So the size, okay. Oh, that's kind of funny, isn't it? It means I don't actually know where I should start in the array, right? I don't know how big the bounds of the array are. So maybe I'll just use a map from v2int to feature. Kind of, as I won't use an array after all. And I could still ask the map, hey, what's your smallest key and what's your largest key? And that doesn't quite actually help, does it? Because there won't be something at each corner, necessarily. I'll have to compute, like, the largest and smallest x that it sees. Which is fine. We can do that. That any key that is present at any key. Okay, so let me go back to my Cabal file, I guess, and get rid of this dang old arrays thing. I don't need you. You stink. Why did I say I wanted a set? Oh, because I wanted to know about how many colors there are. I mean, do I need a map even? Yes. Because I need to look things up by their coordinate without knowing what color they are. Do I need a set? I feel like no. Right? So we'll just import map instead. And I mean, we'll define a trench or something like that. It's a lagoon. Type lagoon is a map from v2 int to order. No, to color? Actually, this kind of is the trench, isn't it? Because we're not using this for being filled in. We'll use this only for the trench walls. And we're not going to explicitly fill in the middle until someone tells us to. We'll just kind of compute how much space the middle would take up using the scan each row algorithm to see if they're inside or outside the trench. Okay. So I think we kind of want a function that dig trench sort of is our function from list of order to trench, right? And then we'll scan over the results of dig trench later. And I think we basically start at 0, 0, right? Hang on, what color are the corners painted? They start in a 1 meter cube hole in the ground. Each trench is listed with the color. But like where they start, is that colored? Presumably this input is a loop, right? Is the color associated with the origin square where you start? Is that the first color you see or the last color you see? Because the last color you see presumably will close the loop of the trench. And similarly, like, you know, when you turn a corner, you have two different dig orders that have you be in the same square. The first one digs you to there, the second one digs you from there. So what color are you supposed to paint the corners of this thing? Okay, interesting. For now, I guess we can assume you painted the color of where you start. I don't know. I think you could do it either way. I'm expecting to do this with a scan L. And that's going to return your starting position as well as everywhere you go to. So it's kind of like we're gonna if we don't try to do something specific, we'll end up painting both where you start and where you end with the color of where you move, and so we'll have overlap where like the corner between this instruction, the first instruction, and the second will be painted by both of them, which would maybe be a problem. I mean, for now, we don't know what we're supposed to do with colors. We could just leave it blank, but I think we should handle it somehow. I suppose one thing we could do is, instead of storing a color, we could store multiple colors. This is kind of fun. Okay, this is kind of cute. I don't think this is necessarily the most practical approach, but advent of code is for playing around, right? So we're going to parameterize the order type. But so normally I would parameterize. Often you parameterize a type. You're like, oh, I want to store an A here. We have orders of colors, but maybe we could have orders of ints or functions or whatever someday. However, you can do something else, which seems kind of interesting. Do you call this higher kinded types? I'm not sure. What you can do is parameterize not with a concrete type, but dig trench needs to be fixed. But with a type constructor that you call. And the idea I have is we'll parse order of identity, and we'll take an order of I don't know about this. I'm a little out of my depth here. We could take order identity, and do we want like applicative or something? I don't know. See, okay, before I figure out what types these things are going to have, my idea is that we can defer the question of how to handle conflicts till later by parameterizing what goes here. And if you choose f is identity, the identity functor, then you just have, identity of color is the same type as color modulo new type unwrapping. So you just are storing a single color there. So that's what I've written here. Is the input definitely has exactly one color for each order. Actually, we shouldn't parameterize the order function at all. It's only the trench that needs to be colored, right? Because we know the order definitely has exactly one color. Okay. But I can parameterize here where I can have... Okay, so anyway. We can have order of identity. But we could choose some other type. For example, we could choose a type like this. We could choose v2, even, if we wanted, right? Maybe, I think. And that would store both colors. Or we could choose a type like const, or flip const or something that chooses one or the other. Right? We could say, well, okay, I'll define for you, but it already exists. Data const a b is just a const of a. The b parameter is thrown away. So if we had an f... So if we used as our f const color, we would, that would be saying it only stores one color, but it's sort of implicitly the last one. I don't know what type class we need, though. Do we need, like, applicative here? So that I can combine two things? Like, I don't know. I'm not quite sure what this higher order type is buying me. But you can imagine, like, if you chose f as maybe, then you could have a trench where some of the bits aren't filled in at all. There's no color there. We don't exactly have that, but if we were filling in the insides of the trench, we would kind of have, like, a map from v2 of int to, oh yeah, there's something here, but it's not colored, it's just the pool of lava. Like, that's something you could do using f as maybe. I think, though, I kind of just want monoid. So that I can, like, say, or even semigroup. So that I can say, okay, here's two things, combine them however you want. That's your problem, not mine. And we could take the first or the second or something like that in our monoid instance. But then, like, you can't store any monoid because it has to be colors, right? So I guess you would be storing an f of color with the constraint that f of color is a monoid? Does that make sense? But then how do you construct an f of color? I guess it also has to be an applicative, so you can call pure to get something in? I guess? Well, you could give it a try. Should be interesting. If applicative f and monoid m take a list of order and build a trench of f of not monoid m, f of, if f of color is a monoid, then we can build you a trench of f of color. Does that make sense? Dig trench is undefined. Does that type check at all? No. Oh, I forgot to write the punctuation. Oh, trench of f, excuse me. Redundant constraints. Yes, I'm not using applicative or monoid. Like, give me a break. I'll get there. So, that's the type signature. Let's write dig trench now without worrying about what specific applicative we'll be working under. And then we can choose first or last or whatever. Yeah, that seems okay. So dig trench of, like, I kind of think it wants to be just m dot from list with, this is the monoid combination operator. In fact, we don't even really need monoid, right? We only need semigroup, because we're never going to have to fabricate an entry. Well, we will. We'll be making an entry with a color, but we'll never have to, like, have empty exist. When we want to put a color into the applicative, we'll use f, the applicative instance. And when we want to combine things, we'll use the semigroup instance. That makes sense. So I think this is just like, we need, it's a little, we have to, like, starting from the origin, we want to like scan to a new position, kind of, right? Like, don't we? We want to iterate over the orders. We want to do some kind of fold starting with with 0, 0. Maybe fold m makes sense in writer. So that I can track where we are and then also output, like, all the things we scanned. I don't know. It seems interesting. I think it would be exec writer. Exec writer. You're gonna need that from let's borrow tell as well to output things. Actually, is there something like tell that takes multiple let me look up writer. Fine. Lazy. Oh, or CPS, huh? Constant space version with a similar interface. I'm not worried about it. So we have a writer. We can exec it. That's great. I don't know why we would need map writer, but whatever. We have tell. I guess you don't really need a function that can tell multiple things, right? Because the W that you're writing is already a monoid. And so you can just tell, if you have like a list X's of things you want to tell all of them, you can just tell of m concat of X's and that'll be fine. Okay. All right, so we want exec writer and tell. I don't know. Maybe this is not the best way to do it, but that's my idea. Because we won't care. Well, fold m underscore actually, because I don't care about. I don't care about the final coordinate we end up at, but the coordinate is what I'll be folding with. So fold m underscore will discard the coordinate and just have an empty state, which I can exec to get, not state, list a log, I don't know what you call it, what the writer accumulates. Fold m, I don't know, go. Starting with 0. 0 is actually being treated as a v2 of int here. But 0, I don't know. It's probably clearer to not use the num instance for that. Where go. What order does fold m take its arguments in? It should be, I would think, the accumulator on the left, the same way that the same way that fold L goes, because fold M is a left fold. Yeah, that makes sense. Yes, the accumulator is on the left. Okay. I had to do this because my Haskell mode is just pretty wimpy and doesn't know about imports. It's just telling you about stuff in Prelude, which fold M is, but fold M underscore isn't. So go of pos, our position, and an order dir len color is something. Well, what it is to first tell the following things. I don't think we actually have a list, right? We want len steps, so what is it I'm telling again? I've forgotten. I'm telling the stuff that we're going to put into the map. Okay. So maybe I do just do a list comprehension here. Pause plus delta offset. I don't know. Pause plus dir times n, maybe. Color. Pure color. Gotta lift it into the f, whatever f is. Where n is from 0 to len. Kind of makes sense, doesn't it? So this is a list of statements we'd like to make. And then we say pure. The new coordinate we're going to be working with is pos plus dir times len. I guess I usually do this with a $sign, right? Wrong F? No. It's saying you have a single... Well, okay, let's go look at the full error message. It's upset that it has a list where it wants a value, or the other way around. I couldn't quite tell which. You expected direction to order to list of v2 of int and an f of color, which I agree, that's what I want. Oh, sure. The problem is here I have to write pure, right? No. Do I? Wait, why am I writing mconcat here at all? I have a list. What is it we're accumulating in our writer? We're accumulating a list of pairs. Oh, I think I just don't mconcat. Because I have a list of pairs. Yeah, of course. Tell already takes a monoidal thing. Okay, and we have a list, and tell will like take that list and combine it with the other lists we have. Okay, getting somewhere. Sure. I don't know. Is pure really what I want there? I think it fixes that type error. The one on line 24, right? Yes. And again, we have to say, there's got to be some way, I don't know, to... Because the issue is, you can multiply a v2 by a scalar, right? I could say 3 here if I wanted, and that's legal. Because v2 has a num instance, num, I can never decide. And num, the multiplication operator in num requires the left and right to be the same type. So a direction times a number, oh no, but a direction can also be a number, so it can take 3 and convert it to a direction. But if you actually have an int, like n, it says, well, you can't multiply you can't multiply a direction by an int. They're different types. So we can use pure of n to lift it. Which I don't think is really quite the right semantic way to talk about it. It'll have the right result, but I feel like this is the wrong abstraction somehow. There's some function in linear I should be using instead, and I just don't know what it is. But it's okay that like pure of n, like let's say n is 3. Pure of n is v2 of 3 and 3. And multiplying 3, 3 by a direction seems a little bit weird. But it does pairwise multiplication, and we know one of the directions in dir is 1 and the other is 0, so like we kind of do get n0 or whatever. It comes out okay, I think. So this is our dig trench function, and it type checks, so it's like probably right. It would be interesting to see what it produces, I guess. So what if I said, instead of doing all this stuff, if I said dig trench dot prepare of that. Now it'll say, I don't know what instance you want me to use, buddy. What? That's not the error I expected. No instance for show of IO of trench F0. Well, fine. Give me this as an IO of trench of list. Yeah. So this parses it into wherever there's a conflict. You can see one here. This is a corner that we thought could have been painted either way, depending on whether you, the first or the second time you kind of visit that. Do you paint as you enter the square or as you leave the square, right? So there's a conflict here. This is where we turned. But if we wanted to, we could say import data monoid first. And if I wanted a trench of first, now, first is wrapped in maybe, huh? That's a little annoying. Is there one that, because we know we won't ever have nothing. I thought there would, I mean, it's, you know, it's not the end of the world, but what's in data monoid, please? I mean, I kind of want something in semigroup, honestly. Is that also in data monoid, or is it its own? I mean, it's a different module. Okay, so semigroup just has the combining operation for monoid. It doesn't have the, like, empty. Well, that's interesting. It actually has this law about how it relates with applicatives and monoids, which I didn't expect. Monads, excuse me. So all, any, yeah, ordering, okay, and if, okay. So first and last are kind of the ones I thought I would use that go, but it's a little annoying that they are just a wrapping around. Ooh, what about alt? Is that what I want? If F is alternative. What does alt do? Yeah, not much, huh? If I look at first, where is it? Aha. I want the one from data semigroup first. Because this one doesn't wrap a maybe, it wraps any value. Aha, okay. So if I didn't realize there were two different instances. If I said I wanted a data semigroup first. Now, yeah, we don't need the maybe wrapper because we know there's always going to be at least one because there's no way to get an empty element. All we have is pure and append, basically. Whereas if we were using the one from monoid, there's also an empty operation, and so it needs a way to say empty, which would be first of nothing. Okay, so that's good to know as well. Let's then import data. Well, I don't know. I don't know what well, the point is I can arbitrarily choose. Let's import data semi-group of first. I like last, actually. We will, because that leads to the trench, to each order painting exactly as many squares as its length, which seems like pleasing property to have, right? The issue with using first is that this R would paint 12 squares, because it would get to the square it's on, and then the 11 squares it moves to. And all the others, this would paint 10, or, yeah, 10. And then this one at the end would only paint 8, and that just doesn't seem very nice. So we have our trench dug out now. And our dig trench function can be used for part 2, even if part 2 tells us how to handle colors in a way different than we guessed. We won't have to change dig trench to account for that. We'll just call it at a different type. For part 1, we'll use last. Let's take a function that gives us the dimensions of the grid, shall we? Dimensions, or bounds? I don't know. Takes a trench of any f at all, because we're not going to look at the colors, so we don't really care what they are, to a pair of v2. It's a little awkward, right? I guess we'll output y's and x's separately. Oh, we're going to get to use even more semi-groups, aren't we? Right, I forgot about that. Let's go look at the one I want to use in a minute here. So we want to use max and min, right? And max in semi-group, it makes sense. It shouldn't have a monoid instance, though, right? Because you can't ask for what is the max of, like, a nothing if you never see any elements. Yeah. And that's fine. It's a little annoying because the type system is going to try to save me from making a mistake, and I'm going to have to tell it that's okay, I know best. Don't you worry, you're a pretty little head about this. Let's actually define a type for bounds, shall we? So that data. You're using x and y. I don't remember what they're for anymore, but for up and for parsing. Data boundary I don't know. Bounds is not an order. What am I talking? Bounds of. Do I really want to put two v2s here? One for x and one for y? Maybe not. Maybe I just want 4 separate arguments. Y min. Well, Yeah, I guess I do kind of want 4 of these, don't I? Oh, you know what I can do? Instead of having to put these crummy little names in here, I can say ybounds is a tuple. Oh, but... Y range or something like that. I want to use the monoid instance to combine these things, and bounds doesn't quite... Let's actually say low is a v2 of int, and so is high. Oops. Deriving show, I guess. We shouldn't need it. I'd like to derive semigroup and monoid here as well, which I think I'll need something from generic, right? Or there's got to be something in generic that does this automatically. Let's find out. GHC.generic. So we can derive generic for that if we want. There's a million instances for that. I don't need to know about those, thanks. So our A is a fixed type. It's the boundary. From, I guess it'll just like, I'll just say via generic, and it'll, I assume it has one for monoid in here somewhere. Oh, I totally do care about the instances, don't I? I exactly want to read this and make sure that monoid is on the list. Monoid and semigroup. It's not in any particular order I can see, which is annoying. Or wait, no, this isn't quite what I want. Is it? I don't know. I see there's generic instances for all these types, but I guess that's not quite what I meant. I want to know what type classes generic participates in, not what types participate in generic. So if I search for semigroup, like, does that show up here somewhere? It does, but I don't know how useful it is. I'm just gonna like try writing it and see if it works. Oh, maybe, hang on. Generically, okay, this, yeah. A data type whose instances are defined generically. Okay. So the instances of this? Yes. I'm actually kind of shocked that the only things you can derive by generically are monoid and semigroup. And the rest are all via generically 1, which is like a higher order thing. There's not as many as I would have thought. But okay, that's fine. I get the ones I want. We do need, though, language deriving via. And I forget if we needed another. I don't think so. Import GHC generics, generic and generically, right? So our bounds. Oh, but they're not both supposed to. Okay, they don't want them to both be v2 of int. That's the point. I want low to be a v2. No. A min of v2 of int, and high to be a max of v2 of int. So we need min, oops, no parentheses there, min and max. Deriving, I think I'm going to remember this right, the syntax. Deriving semigroup via generically bounds? How do you do this stupid generic thing? Did we do it in, like, I think we did it in at least day 16, right? Yes. Oh, I need this as well, huh? That's true, I do. But via, this makes sense. Am I not supposed to write the parentheses or something? Oh, this is a type, not a function. Parser. Did I really mess up my brackets somewhere? When did that happen? This looks right. Honestly, I maybe don't even need to give these names now, right? I can just let their meaning be implicit by their type. So I have deriving via... I mean, no, that would be a type parser. Huh? Oh, it's way down lower. I saw type, and I was like, I thought it was complaining about this type. But if you read the second word of the error message, you'll find out it's upset about this, and all the stuff up there compiles just fine. So, trench of f to bounds. And it's actually a really simple function. Bounds is fold map. I actually need to look up data maps, list of folds. Oh, speaking of data map, we should be importing data map strict. Not that it's going to be a huge issue, but that's the more efficient one, and we don't need the features of the other one. Okay, data map strict. Folds? These are just folding, yeah, these are folding over the, okay. So I just want to get them, I don't care about the values, I just want to get the keys. How do I do such a thing? Not query, I don't think. No, I mean, it must be like conversions to list or something, right? Keys. So we're going to do a fold map over the keys. Fold map, up, go, keys, where go of y, v2 of yx is bounds of min of yx, nope, v2 of yx, and then max of v2 yx, right? Illegal use of multiple consecutive deriving clauses. I have deriving via. Do I need deriving strategies separately? Illegal driving strategy via. It says right there. Language? Okay, very funny. Oh, and I guess I need generic, of course. No instance for monoid bounds arriving from fold map. I forgot. Yeah. Is there some version of fold map that I told you, and then I forgot that GHC was going to stop me from making a mistake, and I was going to have to assure it that I really do know better. The issue is bounds doesn't have a way to like provide a neutral element. It's only a semigroup, not a monoid. Because min and max are only semigroups. You can't say, there's no neutral element for max. If I give you a number, you could always name a smaller number, and so the number I give you can't. Okay, you could use minus infinity, but that's cheating because that's not a number. So the fold map's point is, sure, if there's a bunch of elements in this map, I can give you the biggest and smallest x and y. But if there are no elements at all, then I can't give you anything, and you said I was supposed to be able to give you something. So I mean, I think there's definitely some you can like use maybe basically, right? Maybe bounds. Yeah, okay. So if I say actually it's just this bounds, and we fold map go, and then we say from maybe 0. Is that any better? Are you happier? No, of course, because bounds of 0, 0. Yes. Okay. So we're not using last. I don't remember why I even have that in the import list. Oh, it's because of how I'm planning to... Yeah, okay. So, okay, this now fixes it. And I don't have to cheat. I don't have to tell Haskell I know better. I can say, fine, I'll assuage your concerns. Fold map will always return something, and it'll return a just. And when fold map, where's fold map? Yeah. It'll take the results of all these go calls, which are bounds wrapped in maybes. And if it can't find any, it'll basically skip any nothings, but every just that it sees, it'll look at the bounds inside of the justs, and it'll mconcat those bounds together. And mconcat applied to a bounds takes the minute, if you have two bounds objects, to combine them, is to take the smaller of their y's and put it here, and the smaller of their x's and put it here, and the bigger of their y's and put it here, and the bigger of their x's and put it here. That's what these new types do for you, is provide different ways to combine integers so that we can just say, like, okay, here's the data I have. Don't bother me about how to combine it with other data. Just use the monoid instance. I've already told you how I want them combined. Just go do it, please. So now we have the bounds of an array, or of a list, of a trench. And we can... What do we want to do? Do I want to write part 1 already, or do I want to do something else first? I guess it's fine to write part 1. It should return an int. And part 1 of orders, well, I don't know. Part 1 is the area of dig trench? Where area, I'm going to actually give a type to because I have to specify which f I want to use. is a function from trench of last to int. Let's just make sure that type checks. Yes. Okay. So area of T is we need to it's sum dot map yes, it's sum dot map length dot filter. I don't know. I think it's just actually we want to get the number of lava cells in each row, right? Map lava amount, I guess. On min x, no, min y, max y, right? Sure. Where bounds min of min y, min x, and max y, max x. That one should have been an x. That would have been an expensive. No, it would have been okay to make that mistake because it would have told me, hey, you referred to min x and it doesn't exist. Okay, but these numbers are kind of like a danger point of this function, right? If I pattern match wrong here, I'll be in for a bad time. So I should double check. Min y, min x, max y, max x. Yeah, that looks right to me. Where this is bounds of t. Lava amount of a y is scan this thing from left to right, basically. I want to fold L over the list, I guess. The list of number of x's between min and max. Does that make sense? Or do I just want to filter, like length of filter of lava at? No, because I can't filter. I need to be folding as I go over the list to count how many times I've crossed into and out of the trench. Wait a minute. Can I actually use the approach that I used before of in the pipe program? Because with the pipe, the walls were clearly either vertical or horizontal. Whereas if we just have a hash, well, not a hash, I just know there is a hole here from when I computed the bounds, or the trench. If I see like 3 hashes in a row, or let's say 2, maybe it's fine? No, it's not. You can't just do even odd counting. Because if you have an array like this, right? And let's maybe do a simpler one with just 2. You can't see the rows above or below this, and you get here, and you know this is outside. The question is this inside or not? All this space here. Well, you could say, oh, this wall must be going up, and then this wall is coming down, maybe, and then we've only crossed over the grid once, so this is definitely out. Sorry, and this is definitely in, rather, because we've crossed over the wall once. But it could just be that, like, above is nothing, and below is like this. And so these are necessarily outside. And it could even look like this, where changing the number of hashes here isn't really changing whether this is inside or outside. So actually folding over this is not right. Or just doing even odd counting is not right. That's annoying. Could we? What if we tried, like, to paint around the outside of the grid with, you know, the typical flood fill algorithm with, like, this is definitely not inside the lagoon. And then we compute the area of the entire space we're working in and subtract how much isn't in the lagoon. And that's how much actually is. Does that make sense? Or could I be foiled somehow? Well, if one corner of the space were lagoon, we might have an issue, maybe. But I don't think so. We just have to make sure we only add the non-lava squares to our set of seen things. And I think those 4 corners should always be able to touch everything that isn't filled in, right? Because it's not like pipes where you can have like a really thin section of parallel pipes that don't actually have any space between them. We're digging out entire 1 cubic meter chunks. And if 2 of them touch, then they're just both dug out. So I think that makes sense. Is there some better way to do this, though, than just scanning from the outside and counting how much is there? Like, if we could scan from the inside, that would be great, but it's hard to tell what's the inside. Whereas the outside is easy to identify. So I guess then the lava amount is we're gonna have to do this differently. It's land area minus the size of lava spaces? No, non-lava area, right? The land area is max y minus min y plus 1 times max x minus min x plus 1. Plus 1 because these are both inclusive. And then the non-lava area, non-lava area is go of, kind of annoying. Is there some implementation of flood fill that already exists? I don't know. Probably. Let's look real quick. Maybe it's easier than writing my own. There is one in like some crazy library I'm never going to use. Okay. And it does not do what I want. It's some like image manipulation software, it looks like. Go empty. And our initial... So we're going to maintain a list, I guess, of the open set or something, but I don't know what the right word for it is, where the coordinates we still have to process. Min x, oh, it's v2s. v2 of min y min x, v2 of min y max x, v2 of max y min am I doing this in a dumb way? I am, right? I can just use the list monad here, yes. Go s empty of lift a2 v2 over min y max y and min x max x, right? Import control applicative lift a2. Oh, I do need sets after all, it turns out. Min should have one argument, but is given 2. Yep, that's true. This should be a v2 of min and max. So we haven't implemented Go. I agree. That's fine. If that's the only thing you're mad about, you and I are going to be great friends. Okay, good. So this takes the Cartesian product of the y's and the x's and gives us the 4 ways you could choose one of each. Bundles those up as v2s. Go of scene empty is scene. Go scene x's, I guess. When it is the case that S member X not seen, well, I guess it's fine, is go X's, or if it's a member of, no, if M, how do you ask if a map contains something? Query lookup member, okay. M member X T. If it's a member of the trench, then we should also stop and say, well, we're done investigating this. We found lava. Otherwise, it's go of S insert. What order does insert go in? It should be the key first, right? X scene and Then x plus all of the directions you could go in, right? Fmap x plus over... I mean, it's a lot like what we did yesterday, right? I got like the neighbors, except I changed it, but like this negated basis is kind of, I guess, what I want. Oops, that's not how you paste. That's how you page down. Actually, this is kind of a silly way to do it, isn't it? Instead of using fmap, I should just, and dollar sign, I should just use that, right? Oh. Right, we still have to call scene here, of course. M X. Basis, yes, I did want that from linear vector, please. Yeah? I guess I'm wrong. I didn't want I did want it the way it was before. Fmap that applied to that. Because this is giving me a for tuple, and I want to map a function of one argument over that for tuple. I don't have a function of two arguments that I want to map over two different lists. Okay. Shockingly, this type checks. I don't think it's that likely to be wrong, but I also don't want to say I think it's right. Let's run it and see, though. I mean, it would be fun to run a program for a change. It's been a while since we did that. What are you thinking about? This should be a really fast program, shouldn't it? There's like nothing to do here, right? Uh-oh. You might be in an infinite loop. What's happening? Oh. Right. Cancel. The issue is I'm always giving it 4 coordinates to look at. I meant to add these to x's, but instead I replaced x's with them. Let's try, I don't know, that. I mean, it's probably more efficient to do it this way, because the shorter list and the list we're building now is on the left. Okay, let's try this. It's still taking much longer than it should. This should be over in no time, I think. So if x is part of the trench boundary, or if we've seen x before, we drop it and use the same scene list. Uh-oh. It's using up all the memory on my system. Quick, we gotta kill it. Oh, no. Stop. I started being unable to even, like, scroll or not scroll, move the insert point here. So what have I done wrong here? I guess one kind of interesting thing would be just how big is the area we're digging out? Is it way bigger than I thought it would be? It shouldn't be. We could use part 2 to smuggle out some information, right? Bounds. Bounds. Dig trench. Now this will be ambiguous, right? Yeah, so I have to tell it what type I want. Oh, can I just say dig trench at list? Yeah. Okay, that's what I should have done in the first one, actually, probably. Right, type applications. Oh, wrong function? There. So the issue that we're addressing here is that dig trench works for any f that has, various type class instances. And bounds doesn't care what f is. But Haskell still has to pick an f to apply dig trench at to figure out what constructors to wrap things in and how to combine the elements and so on. And so it says there's no way I can infer what f you wanted me to use for dig trench because you're just calling bounds on it, which ignores the f. In oldie-timey Haskell, you would address this by putting a type signature on or something like that. And you still can, as I did earlier up here. But these days, you can also use type applications saying, hey, if we ask what is the type, dig trench, it says, oh, if f is applicative and also f of color is a semigroup, it's a function from list of order to trench of f. This at symbol says, please replace your first type parameter with last. And so now it's like, oh, okay, great. It's a function from order to trench of last. And the same thing for list and so on. Now the problem with this is that part 2 will still is it possible I just forgot something? No, I don't think this is digging out infinitely sized areas, but maybe it is. Oh. The problem is that I never stopped it from going out of bounds. Okay. Right. That is a little bit annoying. So it's walking out of bounds and exploring this huge area. Okay, so we maybe don't even have to do this part, but I have to fix what happens here. I need another guard clause where when x is out of bounds, we just skip it. I mean, I guess that could be all I do. I thought it would be nice to not generate such a thing to begin with, but you don't want to add it to the scene list because that would stop you, indeed, from progressing past that place, but it would also count it as a non-lava square, which is wrong. So let's say now x is wrong. We'll call it C and C's. Because I want to refer to first of all, this still type checks? Good. I want to pattern match this actually as a v2 of yx. Otherwise, I want it to be like well, I don't know. Maybe that was silly. Put it back, please. I think what we can do here is say case x of, and we know it'll be a v2. That's fine, but we'll pattern match on the result. V2 of, yeah. See, here's where I want. I don't know. I want like a new x. Y x where I assume, okay, well, yeah, we can't really use the ORD instance for v2 because I assume it's like lexicographic or something. If y is less than min y, or y is greater than max y, or x is less than min x, or x is greater than max x, it's prune. We're going to just prune, okay, where prune is go seeing x's. This needs to be, we're in a case, not a function definition, so it's arrows. Otherwise, it's this, right? Okay. Oh, I have a, okay. Oh, I see. I meant to type this. Yeah. Oh, and now the issue is, okay. Yeah, this is why I needed it to be a C after all. Ugh. This type checks, it's pretty gross. I won't argue with you on that. But maybe it works better? It fixes something that I believe was an issue. Yeah, and now we instantly get the result. Interesting that our minimum y was 0, so it never went up from where we started. Maybe to help the people who decided to use arrays or something? I don't know. But x goes negative, so whatever. Yeah, I mean, that's a plausible looking bounds, and does the answer look plausible? I mean, if this entire area were filled with lava, right, we would have 425 times 60-ish, right? How much is that's pretty close to this number, isn't it? 425 times 60? 25.5? This is a little worrying because it looks like the entire The entire area that's within the bounds is almost completely lava. In fact, it might actually be completely lava. Well, no. What's 425 times... The difference between these two is 66, right? I estimated 60, but it's actually 66. 425 times 66. 28,050. Okay. So, I mean, it is mostly lava, but it seems like it's drawn roughly a perimeter around the area. Which, I guess, is plausible. I don't know. Let's put this answer in and see. I would not be surprised if Eric tells me the number here is too high, but at least it's believable. Too low? Eric? Okay. Let's read the problem again and make sure I didn't miss anything up. Mix anything up. So upper north, yeah, east, okay. Starts in a 1 meter cube hole in the ground. I mean, I guess I assumed that this would be circular. Maybe it isn't, but it doesn't matter, right? Because... Like, I mean, it has to be. There has to be an interior, right? If we, like, removed this cell here, what would the trench even be? It wouldn't make sense. It would be open. You would be pouring lava all over the elves and ruining Christmas. So, where does 62 come from? What is the area here? It's 7 by 6, 10, 70. There are 8 missing. Yeah, so that, I think, does sort of represent what I was trying to do. So, in what ways have I done it wrong? Presumably here. I'm pretty confident I dug the trench correctly. Well, I mean, I guess I could be wrong. Let's look at that. Oh, you know what? We could run it on the test input, right? And see if I get the right size trench at least, and the right area there. I guess back to Emacs. Input dot... I forget what I always call... I'm not sure what I'm calling this. Input.test.text or something? I don't know. And I have this vague recollection that there was actually some secret URL you could pass Advent of Code and it would give you the test input as if it were a regular input, rather than having to copy and paste it from the website. But I don't remember what it is. Maybe in day one, in the first year, there was something that told you about that. Maybe I'm imagining it. So if I said then, reload again just in case, what is part 1 prepare over read file input.test.text, please? 68. Okay, that's definitely wrong. Part 2. From 00 to 69. Well, I mean, I think that's right. Yeah, that's right. Oh! But... Look. This is exactly why I'm wrong. I said if you start at the corners... you'll definitely find everything that's not part of... But, like, here's an example. This exact shape has holes in it that aren't at the corners. But you can see why my approach got 68, right? This area is 70, and these two are not in. And I don't locate these two or these four that are not in, right? So I think I actually need to start... I need to add every piece of the edge to my initial open set, right? My work queue. And that should address this problem. And that is in part 1, where I compute the non-lava area. And it's not just this, actually. Go SMT do. Y from min y to max y, x from min x, max x, pure of v2 of yx, please. Not using lift A2 anymore? Okay, get out of here. But I should be, right? Hang on. This should just be lift A2 v2 over a different list. Should be that. Yeah, basically instead of using I should have just replaced the commas with dots and I'd be fine. Okay, fine. Let's see if that's any better. Uh-oh. It's a way bigger... My number was too low, and I shrank it by a factor of 25. Oh, right, of course. Because I don't actually want to combine these pairwise, right? This is just all the X's and all the Y's. It's just telling me only the cells that are part of the trench, basically. Or something like that. I need... min y to max y joined with... well, you need all 4 edges, basically, of the grid. God, this feels so stupid, but... West... West, north, east, south, and I'll figure out how to combine these more intelligently in a second, where... I mean, I don't know. I don't need a new where clause for this, but it seems nice. Where the west edge is what we're defining here. West is... V2 flip. Well, yeah, flip V2 of min x over all the y's, basically, right? X's is min x, max x, and y's is min y, max y. And then we can say east, flip v2 of max x over y's. And a similar thing for north, but it's not flipped. V2 min y mapped over x's, south is v2 of max y over x's. So how was I supposed to write this without all this duplication? What was the right way to do this? I'm building... Okay, first of all, is this type check? Yes. Like, yeah, I don't know. There's not necessarily a great way to do this because there's 4 different numbers that I need here, right? I'm sure you could write this a little more concisely, but this seems not completely insane. Unlike this whole function, which is getting rather long and does seem sort of insane. Hey, what do you mean it's still the same answer? What? Still 1054? Why? So west, north, east, and south are each giving me a list of starting coordinates. I'm concatenating that to get, from a list of list to a list. And so I just have the boundary, basically. And I say go empty, and I pass it the entire edge. And for each such thing, I say, oh, if I've seen this before, you can throw it away. If it's part of the trench, you can throw it away. Otherwise, where are min, y, and min? Okay, they're defined here. If y is less than min y or greater than max y, or x is less than min x or x is greater than max x, we prune it. Otherwise, we add it to the scene set. Wait. Where do I ever check if it's... Oh, right. I check if it's part of the trench in this m call, m.member. I mean, I definitely did submit an answer that was too low, and my answer is now way, way lower. Why? Okay, well, let's run it on the test input again, I guess. That's correct. 62 is correct, right? It is. What? This says 1054. Which is very small. Like, it would have to be impossibly thin to even be that small, right? Maybe this is actually... What's the size of the trench, actually? What if I just said, instead of bounds... I'll just comment out the type signature. I'll say length... No, m.size, I guess is all I want, right? So if we look at the test input, It says 38, which I believe is correct, right? Yeah, that's how long the trench is. So on the real input... Oh, whoops, that's not how that works. The trench has 4,306 cells. So, like, there have to be at least 4,306 lava cells. What am I getting wrong in this computing the non-lava area thing? Maybe my computation of west, east, north, and south are wrong. I mean, they look right. And my computation is the land area minus the size of the non-lava area, which works on the example input. And these min-max not list comprehensions, but ranges are inclusive, which is what we want. So it should start at the edge and never cross over a lava cell, because if it sees one, it would get pruned. If y is out of range, or x is out of range, we prune, which is to just continue ignoring the current point. Otherwise, we add the current element to the set of actual non-lava cells. Because we looked at it, we've never seen it before, it's not lava, and we got here without crossing any lava from the boundary of the map. So that seems legit. And then we say take the remaining coordinates on our Q, C's, and then add the result, the neighbors of C, to it. And somehow we're finding way too many cells. I mean, this looks right. Dig Trench gave us the right result. I mean, everything gave us the right result on the test input. We have the right answer for the test, which is troubling. The land area minus the size of the non-lava area. That computation makes sense. We find all the places that aren't lava, that you can get to from the edge of the map without touching any lava. and we subtract those from the entire universe. Land area should be right? It's max minus the min plus 1 in each direction. So if the max were equal to the min, let's say, for our example, that's the simplest edge case to test, then that would be 1 times 1, an area of size 1. Yep, that makes sense. Computations of north, south, east, and west all make sense. I don't know. Obviously, there's some overlap in, like, west and north both contain the top left point, right? But that's fine, because if it's part of the second time we see it, it'll either be in the scene set, because it wasn't lava, or it'll be lava, which means it'll be part of the trench, and we'll prune it the second time either way. The first time, we may or may not add it to the list. I don't know. I'm gonna take a break. I don't know if I don't really want to end the video here. We'll see. Yeah, I guess just in case. Thanks for watching, and I'll see you next time. All right, I'm back. The thanks for watching was just a prank. I fiddled around with this for a bit, trying to come up with what I could be doing wrong. And it suddenly hit me, I think I'm computing min and max wrong. I should have realized this when one of the numbers was 0, I think. Maybe? I don't know. But I said I shouldn't use the ORD instance for v2s when comparing things here, right? Because they would compare, like, lexicographically, where y is more important than x. But that is actually what I'm doing when I say, oh, I have a min of v2s. I'm comparing v2s by their minimum. What I really wanted, I think, was a v2 of min event and a v2 of max event. Right? So that I can compute the minimum x and the minimum y, not the minimum of xy pairs. Ugh. Okay, so I think that was probably, like, if this caused me to get the wrong x and y, it totally makes sense that I could compute way too big an area that's non-lava, because I'm looking at a bunch of area that's nowhere near where the trench is. So we have to fix this. Can I get away with doing this and just using coerce? I think I can, right? Is it in data coerce, maybe? I don't actually know. Let me just ask Google. It's in... I don't want GHC prim. Unsafe, I don't want. There's one that's not good. Data.coerce, yes. So what is coerce? Oh, I'm pattern matching wrong here. Okay. coerce is a function that is somewhat blessed by the compiler in a way. Well, yeah, its implementation is magical. It allows you to... So Haskell, when you use a new type, we haven't written a lot of those, but a new type is, you know, if we write, I don't know, if instead of type color string, we had written something like, you know, new type, I don't know, a classic. I mean, min and max we've been looking at are new types. They're, you know, a min of int is exactly the same runtime representation as an int, but it's a different type, and therefore it can have different type class implementations. And so the implementation of, like, mconcat in monoid and semigroup is to find the smallest of the two. Whereas a max of int, also the same representation at runtime as an int, but it's using max to implement semigroup. One problem that Haskell used to have is, okay, these new types are great. They're free to wrap and unwrap. So it doesn't cost you anything to add them. But what if you have like a list of int and you want a list of min of int? Kind of the only thing you could do at the time was you could say, I want to map min over the list. And you'll get back a list of min of int, and fine, you know. But it cost you something to build that list. Even though each element you could make for free, you had to build up a new list containing new elements. You could use unsafe coerce, just tell the compiler, trust me, these two types are different, but I know they have the same representation. That was pretty, you know, not great. These days, coercible is a type class that A is coercible to B if A and B are both the same modulo new types, and you have access to the constructors of those new types so that you could write the conversion by hand if you wanted to. And so our a v2 of min of int is the same representationally as a v2 of max of a v2 of int in particular, right? And so when we, where are we, in bounds, when we say coerce C, we're saying, look, I know I have a v2 of int, but I'd like you to pretend it's a v2 of min of int for me. And this one is a v2 of max of int. Perfect. So this needs to be fixed. I haven't like tried running this or anything, but I sort of suspect that this was the only problem. We'll see. Oh yeah, I was fiddling with a bunch of other stuff here. Okay, that's a nice big number. I don't remember what number I put in last time. It was like 25,000 or something, right? And now it's... So, my minimum y is still 0, huh? But the minimum x is smaller than it was. And the maximum x is also larger. Because I think both x's were negative in the old version, right? Okay. So this, let's uncomment this. I had written, what was here before? Land area minus the size of the non-lava area. And apparently we're not using lift A2 after all. Part 2 has no type signature, that's fine. So stack run again and just put the answer somewhere where it's easier to copy paste. Here we go. 61,000. Okay. That's like 2.5 times as big as what I put in last time. And my last one was too low, so that seems right. Okay. Thank God. I hear, by the way, I poked around in the Discord while I was in between during the break, let's say, that part 2 is actually quite hard. So we may well do that in tomorrow's video. But for now, part 2 is input to unit. Part 2 is const unit. There we go. Now we have a warnings clean version to commit. I don't think there's anything I want to like throw away, right? Yeah, that looks good. That's good. All these imports are fine. I'm just committing the whole thing, but I don't know. I like to review what it is. Oh, that wrong new type for bounds killed me. Here I was bragging about how cool it is that Haskell will just do it for us and it's impossible to mix it up. But I had my types wrong, and so it implicitly did not what I meant for it to do. Oh, hang on, we're not done yet. There's a blank line. A18 part 1. I'm still happy with the choice to parameterize this by a functor, trenches. Well, an applicative, really. It doesn't matter for part 1, and I doubt it'll be a big deal for part 2, but I like that we're not going to have to change how we deal with color while digging the trench for part 2. So let's go at least read what part 2 is, and then probably I'll end the video and go think about it for a while, if it's as hard as it sounds. The elves were right to be concerned. The planned lagoon would be much too small. Someone did swap the... Okay. After a few minutes, someone realizes what happened. Someone swapped the color and instruction parameters when producing the dig plan. Uh-oh. They don't try to fix the bug. One of them asks if you can extract the correct instructions from the hexadecimal codes. Each hexadecimal code is 6 digits long. The first 5 encode the distance in meters as a 5-digit hexadecimal number. Oh, this is such a nuisance. My whole parameterizing by a functor thing isn't going to work because I have to interpret the instructions differently. Okay. Last hexadecimal digit encodes the direction to dig. Uh-huh. So 5-digit numbers is how far we're moving. I mean, that is very large. 9 trillion? No. Billion. 900 billion. Well, that is too large to do by hand. They were right about that when the people on Discord said you can't really brute force it. Well, so there was something I saw that someone had posted in the Discord when last time we had to do this measurement thing, which was like day 10 or something, I think, when we built a polygon by following the pipe around. They pointed out 2, I guess, algorithms or formulas relating to polynomials that are defined by a series of points. So like a polynomial is defined by a series of points. And given a polynomial definition, there's a way you can iterate over just its vertices and compute the area that that polygon has. Now, the problem is we don't want the area. We don't have points. We have we don't have points with very thin lines between them, right? We're drawing with really thick lines here. So it turns out there's another equation that relates the area of a polygon and some other quantity to the number of points within that polygon which have integer coordinates. And so it seems like you would want to use that here, right? Because you can use one of these formulas or algorithms or whatever to find the area of the polygon and then ask for how many integer points are within it. Add that to the size of the trench itself, which we have already calculated. I mean, even even the number of... Okay, but we know that the grid... Well, I guess we don't know. We assume that the grid never doubles back on itself. So this is an actual polynomial with disjoint points. In which case, the size of the perimeter is just all of these numbers added together. And the area is the number of integer points contained by it. So, yeah, maybe I'll go look up how to do that, and I don't know. I mean, I can think about some other approaches, but obviously we're not counting to 900 billion by ones anytime soon. And in particular, we can't fit a set of 900... I mean, we could count to 900 billion by ones, I believe. It would not be completely impossible for a computer to do it in a reasonable amount of time. But I can't keep a scene set of 900 billion elements on my machine, sadly. So we need a different approach. And I think this whole, like, leaning on math instead of on simulation seems like the right idea, but maybe I'll come up with another. I guess you guys will find out in the next video. Thanks for watching, and I'll see you next time.